Hello, everybody, and welcome to our presentation about Automate and Scale Configuration Management with AWS OpsWorks. My name is Mark, and I'm Software Development Manager for OpsWorks, and with me is Lead Engineer Jens, and because he's the engineer, he will do the demos. So let's get started. So what to expect from our session today? We want to talk about configuration management and how that helps you to automate your infrastructure. And of course, because we're here at reInvent, we want to talk about how AWS helps you to get configuration management done. And OpsWorks currently offers you two flavors, Chef Automate and Puppet Enterprise in a managed way, and we go a little bit deeper into that later on. And Jens will do 3 live demos with you. And he's using Puppet Enterprise for it because we just launched that 2 weeks ago. So that might be new to you. And let's see how that goes. OK, configuration management. So why should you care? So I was an engineer, and I had to do all kinds of things like configuring my web server, my Rails application, everything. So I messed up that a couple of times because I SSH'd to the box, changed configuration, restarted services. And sometimes I'm a bit sloppy, so things go south. And configuration management is a practice that lets you use code to actually do that in a more reliable way. And you have something that presents the state of your infrastructure that you want to apply over and over again. And because it's code, it's better manageable, at least for me as a developer. And I was the last 2 days at the booth and was talking about all kind of management tools in AWS. And I got a couple of questions. What is CloudFormation and OpsWorks, and where's the difference? Because CloudFormation also has code that turns into infrastructure. So CloudFormation is used to build up your AWS services. So it creates the VPCs, the networks, EC2 instances, DynamoDB, all kinds of things, right? But when it comes to the instance itself that actually runs your application, this is where OpsWorks come into play, and this is where we really concentrate on. So OpsWorks takes care of all the files that are on your system, all the configuration, all the packages, and all the processes that should be running. And we do that with configuration management. Surprise. OK, so let me go a couple of steps back, why that matters even more nowadays in the cloud. So the cloud gives you much more speed and agility, and we talk about that over and over again at reInvent. But when it comes to actually managing all that, you want to have a way to actually be more consistent and reliable. So you need consistency across all your instances that are configured. You want to make sure that all instances are configured the same way. And to make that happen, you define the state of your infrastructure, the desired state, and you want to apply that across the board. So what also is true is now you don't have anymore a central ops team, or maybe not anymore. And it's going more into the developer space where people can get the infrastructure easily because they just have a need for, hey, I want to upgrade the Rails application from 4 to 5. Let me try that out. Let me start a new app server, and I configure it myself. And the developers are smart enough to figure out how they want to do that. But the ops people might be worried about, OK, do they apply the same baseline consistency or the same baseline modules to the system, making sure that they have everything set up to the best practices, to our company policies. And you need, as the people that care about all your infrastructure, you need to have better insights. You want to know about all the nodes that are now coming up and going away. OK, who started them? What are those? If they have the right software on it, do they have NTP configured? Do they have SSH access only without password configured? Or do they even have SSH? Because you might not want that. And to have that insights, you need to have tools that actually give you that, right? And we will show you that in a bit, how that looks like. So your infrastructure becomes self-service. Everyone can boot up a couple of instances and tear them down. But you need to have some way to actually make sure that everything is in the right state. And you need to make sure that you have awareness of what's going on in your system. So when you have everything set up, and that is the easier part, right? So if you boot your instance, you configure Nginx on it, it's listening to the right port, it's configured in the way you like it. That's the easy part. But then company policies about security and so on, they change over time, over and over again. And you need to make sure that the instances are changed with that. You want to have the right software versions on it. So let's say there's a new version of Java, and you have a couple of Tomcat servers still using Java 7. And that's not as performant as it could be. So you want to make sure that you know about, okay, we still have a little bit of legacy here. We need to update that. You need to be aware of what's going on in your system. You want to apply patches because, hey, there's a vulnerability found. So you need to patch your bash shell or your OpenSSH. And you want to have the ability, if you upgrade your system or if you change something, to roll back if needed. It might be that you configure a new system or a new software version, and it has side effects that you didn't expect. So you need to have the ability to roll back one day or one version. Also, and this is one of the things that most people do a lot, is key rotation and user management. So you want to make sure that all the new developers are in the sudoers file so that you don't have to be root to do certain things. You want to make sure that if someone is moving from one team to the other, that access is revoked. And all of those tedious tasks, you can either SSH to, 500 boxes and do it manually, or you have a tool that does that for you. And I talked about all the insights that you need to actually manage your infrastructure in the cloud. And let's ask Jens if he can show you how that looks like if you use Puppet.
Yes. Hey, so let me quickly switch to the demo setup. And yeah, let me show you what you actually get when you use AWS OpsWorks. So we head over to the OpsWorks for Puppet Enterprise console here. And what you will see is basically an overview over your Puppet servers. Zoom in a bit. So you see their names. You also see their health state. You see both of them are healthy. You see actually the version which we are running in. Right now we run the latest Puppet Enterprise release, which is 2017 3.2. And you also see the regions. So if you click on the name, you're presented with the detail page. And I would like to go the detail page from the bottom up. So let's scroll at the bottom. So here you will see your recent backups. We take backups of your system either in a daily or in a weekly fashion. So you are always safe and you can go back in case, just in case. You will also see events. The events will have important system information, for instance, when we create a backup, when the server is undergoing maintenance, when something is wrong. At the very top, you will find some settings about or information about the server. But most importantly, you will also find the link here to the Configuration Manager's native console. So there's Chef Automate. This will guide you to the Chef Automate console. But in Puppet Enterprise, this will bring you to the Puppet Enterprise console. And let's head over there and see what we can actually do with it. So we are asked to log in. And this is the password, or the credentials here are handed out on server creation. So we log in, and again we see an overview page. And in this overview page, you can actually see this demo setup here runs 4 nodes, and actually these 4 nodes run in enforcement mode, which means you have a set of Puppet managed resources, which may be configuration files ensuring that some services started or other services are stopped, and Puppet will actually correct if it finds that this is not configured in the way that it wants you. So it will actually autocorrect things if ever somebody SSHs into this box and manually modifies config files or something. And the good thing here is actually this reports that I have 4 unchanged, 4 nodes reporting no changes. So actually everything is boring, everything is exactly as it should be. The thing is configured and just does what it wants. The other way, you could also run this in no-op mode. This would be to get you started. So Puppet would only detect drift. It would actually detect, oh, a config file is not as you said it should be in code. And you could start easily and get just a couple of informations about it. But nodes not only report back whether something was successful or unsuccessful. They also report back like a great deal of environmental information. That could be information about the hardware, let's say network interfaces, but also things like the software installed or generally the operating system. So in case you run a hybrid infrastructure where you have Windows, Linux, Ubuntu's, RHELs, you can also scope this down easily. So let's say I want to have this overview page, but I want to filter and say, please only show me Amazon Linux boxes. I can apply this filter and suddenly my view changed from 4 nodes, which are totally under control, to only like showing me the details of these 2 nodes, which are actually listed down here. The other thing that I can do, so this is kind of information which is quite recent, but it's still not ad hoc, is I can run ad hoc tasks. Puppet allows me to do this. And one example, for instance, could be you want to know which package version of OpenSSL is deployed across your fleet. Maybe there was something, maybe you just want to know what's currently going on. So we can say, hey, let's run a package task, and we want to query the status of the package. We say we want to query this package, the status of the OpenSSL package, and we can select a node list or lists that we want to, which we want to query on. So now we can basically query these 3 nodes about the status of the OpenSSL package, and we just run this job. And what happens now, like just in this very second, the package information is queried. So we know, my Amazon Linux box runs this version of the OpenSSL package. This is a RHEL 7 box. You have a different version, and also the Ubuntu 16 has also a different version. But the thing to keep in mind, or the possibilities here are really, this Puppet tasks can also run your scripts that you have today. So if, as of today, you have a shell script or something that does a job, you can integrate this very easily and just bring your scripts that you have today.
Okay, thank you, Jens. So, as you've seen, there's a lot of information that you just gather by running the Puppet agent across all your nodes. And the same is true for Chef. So all those systems, they have an agent running on the instance that is reporting back system information. And with Puppet, you can even do ad hoc queries easily and very fast. And this is a good way to start. So even if you don't have everything Puppetized, you can gather information and you can even patch things. So you can run the installation of a new package even if you don't have everything automated, but it will get you started with it, and over time you will get everything in shape how it should be. And let me go a bit deeper on what configuration management means for you. So Puppet and Chef both have a great community that offers a lot of community code modules and configuration code that is in the Chef supermarket and in the Puppet Forge. So you don't have to know exactly how Chef and Puppet modules have to be crafted, because you can start easily by just going to the Chef supermarket or the Puppet Forge and say, hey, I need to configure a new Tomcat server. I don't know great details about it. I just know that I need that for my Java application. So you go there, you grab that configuration code, and you can start with just deploying that. And the cool thing here is that Chef and Puppet both have a DSL that abstracts away the way how you configure it. So instead of having something that tells you, okay, to actually get my Tomcat server installed, I need to go through these 10 steps to make that happen, you just say, okay, I want the Tomcat being started. I want that my logs are in that place. I want to have log rotate, NTP, and a couple of other things so that my server is sane installed. And this is all already in the community code there. And what you can do then, okay, you want to have certain things change. Maybe your Tomcat server should run on port 8081 instead of 8080. So then it's just one line of code that you need to change to actually get that done. And Jens already showed you the insights that you can do. And the other thing is, it's great to have a good overview, but it is not really helpful if you can't change things that look out of the configuration that you have in mind. So With Chef and Puppet, you can apply and reapply the desired state over and over again so that your system is in the state that you actually want to have it in. And OpsWorks offers Chef and Puppet in a managed fashion, but it also has in mind that you want to use more AWS services. And one of the things that is most requested from OpsWorks is an easy way to use auto-scaling, because you want to leverage the cloud, you want to have workloads that go up and down wherever you need. And AWS OpsWorks offers an API that is associate node and disassociate node that you can easily integrate with AWS auto-scaling. And I will show that a bit later in detail. So just to recap, your infrastructure is now in code, in this domain-specific language that Puppet and Chef define. And you define the desired state and not how to get there. And because it's code, it's first of all, you can execute it, mainly on the box that you want to configure, but you can also check it into your Git system so you know exactly what the configuration was yesterday, the day before, and you can review the code changes with your engineers and making sure that everything is in the right way configured. So you can apply all the software development best practices. And what it gives you, because you have this reliability of code that you can execute and you can test, you have a way to automate your infrastructure. And you can repeat it over and over again without having the fear that there's a human error, like I did in my old days as a developer that doesn't know enough. And you have the reliability of a system that applies your changes over and over again and reports back if something is not happening the way it should be. So your system configuration is modeled in code, and you can track it over time, and you can change it over time as your company grows and has different needs. So what is OpsWorks doing for you in that space? So OpsWorks offers you a managed Chef Automate and a managed Puppet enterprise server. And what we do here is we give you an easy way to get your own server. Just with a couple of clicks, you will have it, and you just need, I don't know, a few settings. But this is really easy. And then, when the server is started, we monitor the health. So we monitor the state of your server over the time. We give you automated backups, and we will be able to, we give you the ability to restore your server if something went wrong, or you can create a new server from a backup. And we also, and this is, I think, for many people, the most interesting piece is we auto-upgrade the software on your server. Meaning, when there's a new software coming out from Chef or Puppet, because we partner with them, we have an extensive test cycle to make sure that this is running the right way for you, and we can safely upgrade you. If there's any breaking change in the new release, we will let you choose if you want to upgrade, because it might not apply to you, or you have enough time to actually change things so that you can go to the latest and greatest version. And because I said it's easy to set up, I would like Jens to show how that really looks like.
Yes, so let's see how easy it is to get a Puppet Enterprise server started with AWS OpsWorks. So we have this wizard that lets you create a Puppet Enterprise server in 3 easy steps. So let's say we pick a name for it, DEV331, welcome. And you choose a region. I choose Oregon here. And the next thing you want to choose is actually the instance size. So the Puppet Enterprise server runs on an instance in your account, and we give you some guidance here, like up to how many nodes this Puppet server can actually support. So I choose a mid-sized one, which will actually get me pretty far already. In the next step, the important thing is actually to configure the Puppet Code Manager. The Puppet Code Manager is a component inside the Puppet server that will talk to your Git repository. The Git repository that holds your Puppet modules, that is your control repository. So I never remember my Git URL, so I will just copy paste it from here. And now the one thing to keep in mind is actually, okay, is your repository public? If it is, then you're already done. But most of the time, your repository that holds your Puppet code won't be public, right? It has all the precious details, how you configure your web service, all the dirty details you don't want to talk about, maybe. So it's protected. And if you use code commit, AWS code commit today, you can already use an instance profile to actually enable your Puppet server to check out your code. But if you are more on the side of using an external Git host like GitLab, GitHub, whatever, you can also just create a deploy key which only gives you read-only access. So this is a key that is not able to commit code and alter your code base, but it's just allowed to give read-only access, so your Puppet server can actually talk to your repository and check out the code. In the next step, you can tweak some network settings. For instance, if you want to run the Puppet server in a private VPC, so without a public IP, and have it a bit more shielded. But all of these things are already, like, OpsWorks will pre-fill this with sane defaults. We will detect your default VPC, we will set a subnet, and so on. We will create the service role, the instance profile. Everything has been taken care of. Down here, you can choose actually the maintenance window. This is the time where we will execute updates on your systems, as Mark explained earlier. And you can also say, no, I don't want these backups, but I would recommend to just keep them just in case. So the last page presents us the choices we have made so far. And we just hit launch. And now OpsWorks does its job. It gives you a Puppet Enterprise server. This is going to take some minutes. But you have a progress bar which will just keep you updated. One thing I would like to point out is actually these two boxes down here, which you may overlook if you just click through. One thing is actually the credentials. These are the credentials which you can download that allow you to log into the Puppet Enterprise console. So we download them. And the other thing is actually the starter kit. And the starter kit is a bundle of files, a zip file, and it includes a working demo to just give you a very good head start. And it also includes a getting started guide and a README, which has specific instructions for the server. So it's not just a static file, it's really instructions for this very server. So you can just copy paste them and run through it within a couple of minutes. So we also download the starter kit here, and I will show you in a later demo what we can actually do with it.
Okay, thank you, Jens. So, as I said, AWS OpsWorks has Chef Automate and Puppet Enterprise, and what Jens just showed you, how easy it is to create a Puppet Enterprise server, also applies to a Chef Automate server. It depends on what you actually want to have in your production system. So, but what we learned over the last year actually is that enterprises move away from having this one single server that manages all your infrastructure. So the same way that people use different availability zones and making sure that things are separate from each other, nowadays enterprises move in a way that they want to have teams managing their own Puppet or Chef server, but having the ops team that actually takes care of all the infrastructure, making sure that the baseline profiles for security and for the minimum installation on the systems is up to date and being correct and being very, very recent. So what we see is that enterprises recommend, or they enforce it maybe, that the teams run their own Chef or Puppet server, and the ops team has more time to actually take care of what should be running on those. So they have a Git repository with all the code that must be running, while the teams doing pull requests for their specific use case and configuring maybe their Rails environment, PHP, Tomcat, whatever they need. And that the baseline configuration is shared across multiple teams makes it much easier to handle that there's a baseline security on all the systems applied. So what you get from AWS is usually a service and one bill, and that's the case here as well. So Chef Automate and Puppet Enterprise are both the enterprise products, meaning that you usually would have to pay license fees to either Chef or Puppet. In the case of OpsWorks, you pay it to us over an hourly billing model instead of an upfront license fee. So we wanted to make sure as AWS that you can leverage the cloud how it should be leveraged with spiky workloads. So you don't have to pay for a node that is not around anymore, and you don't have to calculate how many nodes I might have at the end of the year so that I'm compliant with my license agreement. So you will pay as you go. If you have more nodes, you will pay more. If you have less nodes, you don't have to pay for them. And this makes you much more flexible in terms of what you want to do with your servers, and you will just pay as much as needed. And this is the usual way how AWS works. Now, let's go a bit deeper into a bit more technical section. I talked about the auto-scaling groups and how AWS OpsWorks helps you to attend nodes unattended. So AWS has an API, or AWS OpsWorks has an API that lets you attach a new node to a server in a reliable way. That is backed by identity and access management by IAM instance profile. So the IAM instance profile needs to let you call that API on the OpsWorks, this API call on the OpsWorks API, so that we then can establish trust between a node and a server. And this helps you to integrate it with auto-scaling because we give you, as an example in the starter kit, a user data script that is ready to go. You can just use that, paste it into either auto-scaling, CloudFormation, or an EC2 launch wizard, and start new instances with that instance profile that automatically connect to the server and being provisioned in the way it should be. So how was that done before? With Chef, you usually have an operator workstation that has a key that allows you to create nodes. And with the tool Knife, which is, Chef is everything about cooking. So Chef has a knife, so that's the tool it uses. So with Knife Bootstrap, you create or you install a client on a node that has a key that is trusted by the Chef server. So when you run from your operator workstation Knife Bootstrap on an EC2 instance, it installs the Chef client in a certain version, and then it can start being provisioned by Chef. Puppet does it a bit different. So in Puppet, there's a third signing request sent to the Puppet master. Then the next step is to verify that the node that sent the request is able to be provisioned by Puppet. And this step can be either manual, or you have some manual code that you write to actually make sure that, okay, only nodes from that region, from this account, and with those tags can be connected to the Puppet server. When that is approved, then the node can receive the catalog of the configuration settings, and it will send back the results of the first Puppet run and the facts. So how does that look like with OpsWorks? So we wanted to get rid of the central workstation approach that Chef has, and we wanted to make sure that also the verification step is eased up for you. So how we do that is when you start the node creates a certificate or a key that's sent to our API. Our API manages the server, so we can place it in Chef and Puppet so that the trust is established because we can manage both sides, right? And then when our API call returns success, you can start provisioning your nodes. And this makes it much, much easier to get new nodes on a server. And when you go through our user and through our starter kit demo, that's exactly how you would do that. And within, I would say, maybe 20, 25 minutes, you have a working example from getting a Puppet server until the first node is connected, Nginx is on it, and there's a website already on it. So the starter kit gives you not only the quick start and the workstation configuration to use Knife and to use the Puppet client tools, but it also gives you a working example how to provision your first node within, 2 minutes maybe. And what we used for that is the Nginx module from the Puppet Forge. We changed a couple of things, and we just have one HTML file that we deploy. This is really, really easy. So having this code, it's maybe a couple of lines. It's maybe something like 5 lines to have your first Nginx set up with Puppet and having a working HTML website online. And then you deploy that with your user data. You just put that in CloudFormation, the EC2 launch wizard, auto-scaling group. It boots up, will be configured, and the website is online. This is pretty neat. Let's, because we show you Puppet all the time, let's have a quick look at OpsWorks for Chef Automate, and you will see a lot of resources online. I talked about that for the last year. So what we give you currently is the Chef Server 12.16.4 and Chef Automate with Chef Compliance 1.6.179. And I want to point that out. This is a big strength of Chef. Compliance is something where you can run compliance checks across all the nodes that are connected to that server. Also, if you don't want to configure your nodes with Chef, that might be a good idea, because you can use the CIS profiles for security hardening, run them against your nodes, figuring out, oh, my SSH is not as good set up as I thought, and taking action. And this is where Chef really shines. It also, if you look at this page, you see that the last run was successful. It gives you some details about the nodes. You see a history of which runs actually were successful and if everything was fine. The Puppet console you've seen already. We give you Puppet Server 2017.3.2, which is the latest and greatest. It has the Puppet 5 platform, which is backwards compatible to Puppet 4. If you're still using some older modules, that should work. And we pre-configured with Puppet Code Manager. Puppet Code Manager is the best approach to actually build Puppet modules, deploying them to your server, having them in Git stored and versioned and tested, and then running or building catalogs out of that and deploying that to all your nodes. And already Jens talked about Puppet Task. This is also just released in October. And Puppet Task gives you the ability to do ad hoc runs. So if you're not having everything already set up the way Puppet would love to have it, you can still configure your nodes across the board with just having your bash scripts that you probably have already. And you can run them reliably across the whole fleet. Puppet Task is very, very unopinionated. If it should be a bash script or something else, they can configure. So you have multiple options to do that. And there are some pre-configured things like installing packages, for example. But let's go to the third demo, and Jens can show you how the starter kit and provisioning works, and having an end-to-end example with autoscaling groups.
Yes, so let me show you how it actually works. I would like to walk you through the steps of, I have my starter kit. Let's take a look at it, what is actually included there. So I SSH to my demo workstation, get my tmux session back, and let's take a look what's actually included. Sorry. So yes, you will have the user data that we talked about a couple of times already. You will see it later. You have the README with all the instructions, but you will also find a control repo. And the control repo actually includes the example, which will configure the Nginx, the famous Nginx we talk about so often here. So this is a pretty static website, and I wanted to show you how we actually deploy a change. So let's change something. Let's find our index HTML page and edit it. Let's say, see you at the party tonight. So now if we go into our control repo, we can see that we actually have modification here, and we can commit it. So one thing you already did at this point is you treat your infrastructure as code, right? You attach additional information like this commit message and say, yes, you don't go just to some server and change a setting. You already start to document it. And as we already pointed out, you can now apply software best practices to it. So you could say, oh, you want to code review, you put it up on GitHub or some other thing where you can send a pull request, people review it, people merge it, and so on. But in the end, you push it to your code repository. So we push it now. So now our code change actually left my local workstation and made it onto the corporate repository. And the next thing I would like to do is actually make my Puppet server aware of it. So enable the Puppet code manager and say, hey, Puppet code manager, please pull these latest changes. And One way to do this is actually you could have a CI/CD system, right? You could run code pipelines that now trigger on this change, apply some linting, some syntax checking, whatever you want. But if you are not that sophisticated, or you can already start today by just installing the Puppet client tools and use these command line tools to talk to your Puppet server in a very nice fashion and through an API. So I will do that for the sake of the demo. And first thing we do is we log into the Puppet server. We actually create an API token like that, and we use the same credentials that we actually use to log into the UI. So now we have generated an API to access token that is valid for a certain amount of time. And using that, we can actually say Puppet code, deploy all of our environments, and we want to wait until the deployment has been done. So now our code basically left the code that I changed left my workstation, made it to the corporate repository. Now the Puppet master already picked it up. So how do we go from here? So you have a couple of options. One thing, of course, is you can use Puppet tasks, which I showed earlier, or Puppet. You can trigger ad hoc Puppet runs to immediately tell your fleet, hey, pick up this change now. The other thing that you can do, the Puppet nodes check in a regular interval. By default, it's every 30 minutes. So over the course of the next half an hour, basically all your fleet would gradually pick up these changes and it would be rolled out. But for the sake of the demo, I will show you how easy it is to actually bootstrap new instances with this code, and I will use an autoscaling group to do this. So we just head over to the EC2 console and create an autoscaling group. An autoscaling group under the hood consists of two pieces, a launch configuration and autoscaling group. So we create a launch configuration first. And the first choice we make is the choice of the operating system. I choose Amazon Linux. I choose a medium-sized G2 instance. And in this third step, it's actually where I can choose a name. One thing to configure is actually the IAM role. The IAM role will give the EC2 instance, which is launched, the permission to actually register itself with the Puppet node. So this IAM role, here it's called Puppet node instance. In case you wonder how this is created, this is also part of the starter kit. So there you will find like a one-liner, you copy-paste it. It's actually backed by a CloudFormation template, which will create this instance profile in your account. So that's already been taken care of. In the advanced section, we actually now finally use the user data that we talk so much about, but it's actually also pretty boring because it's just a copy-paste thing. We don't need to modify it or do anything with it. We also don't add extra storage. But what we want to do as I bring up a web server is I want to configure the security group. So SSH access is not needed. We can shut this down. But I add a rule to allow incoming HTTP traffic on port 80. I can review all my changes. But finally, I create the launch configuration. I have to confirm this one here. So now I have a launch configuration, which is the first step to get the first out of two steps to actually get my autoscaling group configured. So now I can create an autoscaling group based on this launch configuration. Again, I have to give this autoscaling group a name. I can choose an instance, the number of instances which this group will pick up. I can say, hey, let's configure 50, but actually Amazon is a frugal company, so I will just boot 2. I can select the subnets in which the instances will be created and configure scaling policies. Scaling policies would apply if you want to scale up and down on certain metrics, like let's say your load goes high, or you could even predict your load pattern, right? If you know customers or developers come in and go at certain office hours. I'm not interested in notifications, but the thing I'm interested in is tags for this auto-scaling group. So one thing I would definitely recommend is supply a name tag, because this will always make it easy for you if you ever go to the EC2 console to actually identify the instances somehow. This is the tag that you see there. The other thing to configure via tags is actually assign a role to an instance. So your Puppet server knows basically about everything about your instances. So it knows how to configure a web server, how to configure a proxy server, how to configure your transcoding server, everything. But what we need to do is actually, we need somehow to tell, okay, this is an instance that should become a caching server, or this is an instance that become a web server. And we do this via roles. Like a role is, so to say, like the purpose of the machine that you give it. And to do this, you configure the pp role tag here, and we say this should be an Nginx web server, which surprisingly matches the role which we have included in the example. Other tags which you could include, like, is any meta information that's interesting for you. So I don't know, maybe your company wants to have a cost center tag or anything on it. Like, you can go wild. You have like 47 remaining here. And again, we can review everything and start our auto-scaling group. So now EC2 auto-scaling is busy. Basically, we can see, oh, at the moment there's 0 instances, but we want to have 2 of them. So we can head over at the Instances tab and actually see how these instances are created. And while we give them a couple of seconds to actually boot up and configure themselves, I will again walk you through what's actually going on under the hood, so you know what actually the work that you don't have to do anymore. Let's say it a bit like that. So the instance will actually talk to OpsWorks and say, hey, give me a certificate so that I can identify the server. So now the EC2 instance knows, okay, this is a server that is trustworthy, or I can identify it in a secure fashion. Then it will talk to that server and say, please give me the Puppet node for my operating system. We have included Puppet agents for Red Hat 6, 7, 2 versions of Ubuntu, and of course Amazon Linux. Puppet agent for Windows is included as well. So the EC2 instance actually goes and fetches the software, installs the software, and then it reaches out to the OpsWorks API using the associate node API call. And as it has the IAM profile, which the instance profile, which we configured earlier on, it has the permissions to say, hey, please register. I am node number 1 or node number 2 in our example. Please register myself with this very Puppet server. So OpsWorks is taking the appropriate steps to actually configure this. And as a result, now these 2 entities have a trust relationship, right? The Puppet server knows this is a node I can trust, because you don't want to hand out your catalog changes or the way how you configure it to everybody on the internet, right? Like not every node should drop by and say, hey, please tell me how you configure your database servers. It should be like in an authenticated fashion. And the other way around, also the node knows this can be trusted. So let's see if this actually worked out. We actually head over to the instance, and we copy the DNS here. And if everything went fine, we should actually see our web page where we actually see the change which we introduced. So just to recap, we made our change to one of the Puppet modules, like a tiny change. We pushed it to the Git repository. The Puppet client tools give us an easy way to actually deploy our code change on the Puppet master. And then we use the auto-scaling group to just boot new instances, and all of this in just a couple of minutes.
Thank you, Jens. So you've seen it's pretty easy to get started, but I want to recap what we had in this session today. So we care about the configuration of all your instances, and to make it in a good way is we model that as code that we can reapply over and over again, so that your instance is not only bootstrapped once correctly, but you can change it over time, reliable, and you can patch it wherever you need. And the easiest way to do that is having something that is continuously running for your servers and reapplying the desired state over and over again. And you make changes so that the desired state actually matches the last state of the art. And what we also have seen is that the EC2 autoscaling integration is very, very easy because we did the heavy lifting of providing you with the user data that you can just use. And OpsWorks itself is managing the server for you, so you don't have to take care of the Puppet enterprise server or the Chef Automate server. This is covered for you. We upgrade, we patch that, it's running, we make sure that it's running for a long time, and you can make sure that you write the code that actually should be configuring your nodes. We have some time for questions, but I would also appreciate if you meet us at the management tool booth that is in the expo hall on the very end where AWS is, and then on the right. Puppet and Chef also have their booths there, so if you have specific questions how a Puppet module should look like, how a Chef codebook should be written, and having some deep questions there, you will find the expert at their booths. And you can hang out with us at the village, and probably someone will run into us at the party tonight. We will be there for a long time, I think. Also, don't hesitate to tweet us. And now I would like to hear if you have any questions.